Hello guys, today we will be solving the letter case permutation problem from Leetcode. So let us look at the problem statement first. So it says that given a string s, we can transform every individual letters to be a lowercase or an uppercase to create another string. So we have to return the list of all possible strings that we can create. The output can be in any order. So talking about this particular string, if we check this particular string here as a is a letter. So it can be transformed into a smaller case and also a bigger in its uppercase part. So similarly, here we have A. So there would be two subproblems, one with smaller a and one with uppercase A. Similarly, we have B. So it would be divided into two subproblems, one with capital B and one with small b. So there are multiple ways to solve this problem. One of the very intuitive way is using backtracking. So let me just explain you that. So let us consider this as the string which we have, and this is the string which we have in until now. So how are we going to solve it is that we would have an index which would initially point at the first part, and we would check that the character of that particular index is a is a uppercase or a lowercase letter or not. Basically, it's a character or not. It's an letter or like alphabet or no. If it's an alphabet, we would divide our problem into two subparts, one with the smaller a, another one with capital A. And also we will increment the index. So index initially was at 0. So now the index is pointing at 1 for both the subproblems. So again, uh, if the character at that index is not an alphabet, we would not do anything. We would just go ahead. So the new index would be something like this. Okay, for this one. So here, when we will again check if the character at this index is equal to is a is a character or not. It's a basically alphabet or not. So in this case, it's an alphabet. So again, it would be subdivided into two subproblems. Uh, A1 small b2 and A1 capital B2. And also the index would be something like this. Okay. So again, as this are not equal to, it's not equal to a character, this index will again move ahead, and that is the part where the recursion would stop. This thing would be taken into an answer, and the control would go to its previous caller. Similarly, it would come here. It would increment this index, so the index would be equal to the size of the element. It would stop its recursion, store it as the answer, and it would go back. The recursion call would go back over here, and so on. So ultimately, from this to here, to here, to here. A similar thing will be happening on the other subproblems as well. So from here, the index would change to this B, and since it's an alphabet, it would be subdivided into two problems. So the first problem would be this one, and the second subproblem would be this one. And eventually, it would also traverse through all the elements, and this would be stored as the result. It would be returned. Similarly, this would be stored as the result, and it would be returned back, and so on. The recursion stack would go on. So I hope you are able to get the gist of the problem, how it would be solved. Maybe we can check the code now. So yeah, this is the code which we have. So this is the array which would store the actual result, the result array. And this is the method which I'm calling, and I'm passing it as a parameter over there. And this is the initial solution which we have created. So initially we do not have anything inside our result array, right? So it would be something like this, an empty string. So now inside this function, I would be checking if this partial solution, right? If the string which I am creating, which was initially empty, if that is equal to the length of the target string. If that's the case, I would get my result and I would return. So basically this particular thing is for this particular cases, is for this particular case, all these cases, four cases. Basically that's the base condition for your recursive code. Other than that, if it's I will get the character at that particular index, I would check if that is an alphabet. If that's an alphabet, then I would recursively call this particular same method. So here if you check, I am calling it using a lowercase, and I'm converting it into an uppercase and calling the same function again. So basically this is the step at this particular position if you check it. So let's say if it's a character, this step is corresponding to this particular thing. There are two subproblems which we have been calling, one with the lowercase and one with the uppercase. And and if let's say there is if that particular thing is not an alphabet, right? So in that case, it should be the same thing whichever is there, right? Like it should take one itself, right? It should not divide it into any subproblem. So this would come in the else part. So let's say if it's not a character, it would just take the partial solution which was there, and it would just append the current character which is there. That is basically a number every time, and so on. So after this thing is done, you would get the answer in the result, and from here you can return the result. Maybe just check if it's working fine or not. Yeah, it's working fine. Okay. So I think talking about the time complexity, in worst case, we could have all the elements as alphabets, and for every alphabet we would be having two different splits, right? So I think the time complexity would be uh, exponential 2 raised to n, because for every in worst case for every character we would have we will split it twice. The time complexity would be that, and uh, the space complexity would be maybe the result, because that is what we are storing it. So I think the space complexity would be big O of n in this case. The time complexity would be this, space complexity would be this. Okay, I hope you are able to understand it. Thank you.